multiplying and dividing rational expressions. Tax day! So remembering how to multiply fractions, we multiply across 2 times 5, 3 times 4, and we reduce. Or we could reduce along the way. We could have seen that 2 goes into 4 twice, and then I could have seen how it reduced to 5, 6. The bottom, it's really important to realize we keep, change, flip. Or at least this portion, when you divide by a fraction, I'm really going to change division to multiplication and flip the fraction. So this problem goes to 2/3 times a flipped fraction 4/5, but notice the multiplication symbol of 5, 6. So I'm going to keep. I keep the 5, 6, but I know it's a division. So I will change this to multiplication and flip the fraction following it. And then I multiply across and cancel along the way. So if I see something in the numerator that can be divided by the denominator, or 5 divided by 5 is just 1. Can anything else cancel? I see a 6 and a 2. So this, if I multiply across, 1 times 4 times 1 times 4, we get 16 over 3 times 1 times 3 times 3, 27. This skill of going from dividing of a fraction to multiplying by its reciprocal. If I see a multiplication symbol in the middle, I just keep what I see. We will be simplifying 4x minus 4x squared divided by the quantity x squared plus 2x minus 3 times x squared plus x minus 6 all over 4x. So the first thing I'm going to notice is what the operations are in the problem. I just have multiplication, so I don't have to change, flip, anything. I keep it as the fractions that I see. With rational expressions, though, if I want to cancel or reduce the fraction, simplify the fraction in any way, I have to put them in factored form. I got to see, okay, do we have a greatest common factor? Can I multiply, add? Can I do bottoms up method? Or, like in this denominator, 4 times x is already written in its factors. This is just something simple, a monomial. In the first numerator, I can pull out a 4x, and I'm given 1 minus x. In the denominator, I'll do multiply, add. What multiplies to negative 3 adds and gives me 2. In the next numerator, multiply, add method, what multiplies to negative 6 adds and gives me 1. And then the denominator is just 4x. I have to see what in the numerator and what in the denominator would create 1. They've got to be the exact same. So because 4x's are the exact same, each of them can cancel or can reduce to 1. I look through. Sometimes we can pull out a negative symbol and we can get same exact entities. Thank you. Someone just realized that I've got to change that bottom denominator to x plus 3. Sometimes things are going to look extremely similar. Oh, so similar. These guys look really familiar or really similar, but they're not the exact same. Sometimes, though, I could take out a negative 1. If I took a negative 1 out of this, I get negative 1 plus x. Wait, negative 1 plus x. That means the 1 would be negative, the x would be positive, which would match the negative 1 being here and the x being positive here. Sometimes taking out a negative 1 would be helpful to reduce. Watch the next step. Again, pulled out a negative 1 out of that first parentheses, turning it into x minus 1. So let's show all the canceling. We said earlier the 4x's are the same on the numerator and in the denominator. We now see the x minus 1 all the same, and we also probably see x plus 3's are the same. So now I multiply across. I have negative 1 times x minus 2 in the numerator. And then in the denominator I have 1 times 1 times 1. This can simplify to, if I distribute the negative 1, negative x plus 2 all over 1, or just negative x plus 2. Or we could write that as 2 minus x. Any of those are okay. So if I notice, the main thing is if I notice two parentheses that are extremely similar but their signs are switched, take out a negative 1, and then you'll see they can cancel. The first thing when looking at a problem is trying to figure out what operations you have, because the first step will be to keep, change, flip if I have a division. I do have a division sign, so I'll be changing that to multiplication and flipping the second fraction. If it's not written in a fraction, we assume that it's over 1, and I will make this 1 over 3x minus 1. Now I'm ready to factor. Well, since yesterday we reviewed a little bit about bottoms up, whenever I don't have a 1 as leading coefficient, bottoms up is pretty helpful. If I take the leading coefficient times the constant and try to figure out, okay, factors of negative 18 that'll add and give me 7. 9 and negative 2. So in that numerator, for bottoms up method, if I say positive 9, negative 2, I write them in, but then I have to divide them by the leading coefficient 6. The reason why it's called bottoms up is if this simplifies to an integer, I keep it. If it does not simplify to an integer, I will put the bottom up to be a coefficient. Neither of them reduce to a whole number or an integer, so I'm going to put each one of their denominators up as coefficients in their own parenthesis. So this factors into 2x plus 3 and 3x minus 1. This was all just to factor that numerator. So I'm going to write off to the side of the factored form. Writing it in factored form, I believe we see what can cancel. That 3x minus 1 matches in the numerator and in the denominator. So I'm left with 2x plus 3 in the numerator times 1, which just leaves us with 2x minus 3. And x minus 1 times 1, which leaves us with x minus 1. Something I want to stress that we're so inclined to do is realize, oh, wait a second, I have x and x in the numerator and the denominator. I cannot cancel these guys out because they're being held together by addition and subtraction. Unless it's completely held by multiplication. Notice how this 3x minus 1 was being multiplied by another parenthesis. This 3x minus 1 was being multiplied by another binomial. When you have strict multiplication going on, I can cancel. But this has addition and subtraction going on right by it. Can't do it. This is my final answer. So we get to really complicated examples where we're going to simplify. Get 3 expressions. Or 4 expressions. First thing I'm going to do is address the symbols. I have multiplication, so I'm going to keep 4x plus 1. I might, since I'm multiplying by fractions, have to put it over 1. I'm going to change that division to multiplication and flip that second fraction that it's attached to. I'm ready to completely factor this. I've got a monomial x in the numerator. This binomial x plus 3 cannot be factored. 4x plus 1 cannot be factored. 1 is a monomial. It's just it. X plus 3 cannot be factored. 16x squared minus 1, well, I see the squared here, so I check to see if I can factor. And this is actually an example where 16x squared is a perfect squared, 1 is a perfect squared, it's a difference of squares. 16x squared minus 1 turns into, I take 16x squared, take the square root of it, and I get a 4 and an x, so I write 4x as the first term. And then I'll have plus 1 and minus 1 in the back. Now I'm ready to cancel. I see what's the same on top and on bottom. And I have to realize this 4x plus 1 is being multiplied on both sides. This x in the numerator is being multiplied on both sides. X plus 3 in the denominator is being multiplied. X plus 3 in that last numerator is also being multiplied. So I'm going to cancel any group I see that is the same. You see it. I'm left with x in the numerator, 4x minus 1 in the denominator. Again, because this 4x, or because this x is attached with a subtraction sign on its right side, I cannot undo this. I'm left with x over 4x minus 1. I want to make a little note with this last example. If there was something being multiplied on the end here, like x plus 2 over x squared plus 5x minus 3. I flip this fraction. So I change this division to multiplication and I would flip this fraction, but I do not touch this next fraction. I keep it multiplying by the fraction that I see. When I see division, I only change or flip the fraction that's following it. Just wanted to stress that before you hit homework. Quiz Friday will be over 9.1 and this, or 9.1 to 9.4. It is a partner quiz, but you can expect this stuff to be on the quiz as well.